All right, 7th graders, lesson 62, classifying triangles. We remember a few things here about angles. If I have an angle that looks like that with that symbol in the corner, that's going to be a right angle. Anything less than 90 then is going to be acute, and anything greater than 90 is going to be obtuse. We classify triangles the same way. Look at their angles, and in this triangle we find one right angle, so this is a right triangle. In this triangle, all of the angles are less than 90, so these are all less than 90, so they are acute. And in my last one here, this would be an obtuse triangle because one angle is obtuse. This is acute and this is acute. So a triangle will always have two acute angles. There's no way we can get around that. These two are acute. We can say these two are acute and these two are acute. But what we're looking at is we classify by the third angle. So we have to check all three angles to decide on what type of triangle shape is going to be. Now, we should also remember that the total of all the angles in any triangle will be 360 degrees. So in this triangle I have a 90-degree angle here, and if I say that this one is 30, I know that this one will be 60. 30 and 60 is 90, 90 plus 90 is 180. Need to go back there, not 360, sorry, but 180 degrees. So the interior angles, the triangle should equal 180 degrees. Alright, here's another interesting fact about triangles. I'm going to say this is 90. Say this is 30, and this is 60. And we want to talk about the length of the sides, so I'm going to name this A, B, and C. And so I'm going to ask you, which angle is the largest angle? And if you would correctly say, well, the 90-degree angle, you would be correct. And if I asked you which is the longest side, you would say, well, that side BC is the longest. And you would also be correct. And there is a fact, a truth about triangles, that if you go from the angle, that's the largest, which in this case is the 90-degree angle, and you go to the opposite side, that will be the longest side. So because the 90-degree angle is our largest angle, it's going to be across from the longest side, this side over here. Now let's take a look at the smallest angle. That's 30 degrees. And it is opposite of this side over here, CA, and that's the smallest side. So the smallest angle is across from the smallest side. And then obviously we would get to angle C up here, which is 60, which would be across from this side over here. So if we wanted to organize these sides by length, even though we don't have any numbers there, because of the angle measures, we can say confidently that the smallest, so we'll go from smallest to largest, the smallest is AC. Next is BA, and finally the longest is BC. So this will be the longest over here. So we can figure out the lengths of each side, not give them a number, but at least figure out which is the longest based on angle measure. This is a nice triangle. It's pretty obvious, but we're going to work out next on one that's not so obvious. Here's a triangle that looks like it's equilateral, but it is not. And the reason is because an equilateral triangle has to have all things equal, including the angles. And in this case, we don't have that. We see I've got a 60-degree angle, but the other two are not 60. This one is 61, so therefore this one would be 59. And in example 1, it says name the sides of this triangle in order from shortest to longest. Shortest to longest. Alright, we'll do that. The smallest angle is 59, and the side that is opposite is this one down here. Now, I should label W, X, and Y just like your book has it, so that we can say the shortest side is opposite of the smallest angle. So side X, Y is the shortest. Alright, and the longest, well, 61 is the biggest angle, and the side that's opposite 61 is this one, WX here. So that's going to be the longest, WX, which leaves 60 is the middle number between 59 and 61, and this side is opposite 61, so WY will be the next one. So we've ordered them from shortest to longest based on their angle measure. We don't know exactly their length, but we can say which one is largest and which one is smallest. In example 2, which sides of this triangle are the same length? So we've got a triangle here, QRS, and I say this is 58 here, and this is 61 over here. Triangle has to equal 180 degrees, so I'm going to need another 61 over here. That'll equal 180. So now it's asking which sides are the same length. Well, they would be the ones that are opposite of the two 61s. Here's a 61. Opposite of it is QS, so I would say side QS. And here's 61, and opposite of it is this side down here. So S and R. So that would be your answer. The two sides that are equal in length are QS and SR. And then QR, this one over here, is going to be a little bit smaller than those two because 58 is smaller than 61. Alright, example 3, you've got JKL, and they say every side is exactly the same length, which means this is an equilateral triangle, which means all of the angles are going to be 60 degrees. So the book is asking just for angle J, so you can put down that angle J is going to equal 60 degrees since all sides are equal. We're going to go on to classifying triangles a different way besides right, acute, and obtuse. This, because it's all sides are the same length and all angles are the same, we call it an equal. So you start with the word equal. Well, it's actually a little bit different. It's got an I in there. Equilateral triangle. The next type of triangle is, so all of these sides match, is what if I have two sides that match? This side matches this side, but not the third side. That is an isosceles triangle. And finally, you have what we call a scalene. And it has all different angle measures and lengths. So an equilateral triangle, all of the angles are the same. In an isosceles, these two angles are the same. And in the scalene, they are all different. Every side is a different length. Usually we call these, also you'll hear the name regular triangles. All sides are the same length. So a regular rectangle would be a square, regular pentagon, regular hexagon. Those are all types of things that we use, but regular just means all sides. In example 4, we're talking about the perimeter of an equilateral triangle is 2 feet. So the whole distance around is 2 feet, and it's an equilateral triangle, so every side is exactly the same length. And they want to know how many inches long is each side. So I'm going to convert this to 24 inches. 2 feet is 24 inches. I've got 3 sides. 24 divided by 3 is 8. So my answer here would be each side would be 8 inches. Alright, and example 5 here, draw an isosceles right triangle. Isosceles means 2 sides of the same length. It's got to be a right triangle. I'll connect those there. So this side is the same length as that side, and I've got a right angle in the corner, so I've drawn an isosceles right triangle. Alright, that's it for today. You can get started on lesson 62, 7th graders.